All right, so today we're going to talk about linear speed and angular speed. And linear speed is the rate at which the object moves along the path outside. So this is how fast. So the way that you use that is like when your tire rotates on your car, right? So the outside of the tire. The angular speed is how fast the central angle is rotating around. Like the whole pie part, how fast it rotates, okay? So linear speed, we're going to use S over T, which is the arc length from yesterday, over time. And the angular speed is going to be theta over time. And the theta is our central angle. So if we're talking about a wheel that's rotating, so how many degrees to rotate all the way around? 360, right? But we said when we talk about central angles, it has to be radians. So what would the circle be in radians? So if it's 360, it's 2 pi, right? So one trip around is going to give me 2 pi radians. So for question number 1, a bicycle tire with a radius of 14. So here's my radius, right? My radius is 14. Rotates at a rate of 125 revolutions per minute. So I know that you all hate, right? Everybody hates the word problems. So no matter what, every single one of these, you start the exact same way. No matter what information they give you, you have to start by finding theta every single time. And I'm going to find theta by asking you, how many times is this wheel going to rotate? How many times in the problem did it tell you it rotates?
14.
Yeah, there's 2 numbers. There's 14. You had a 50-50 shot, and you picked the radius. It rotates 125 times, right? And if it rotates 125 times, it goes 2 pi single time, doesn't it? So I'm going to find theta by multiplying 2 pi times the number of revolutions. So when I do that, I want an exact answer, so I'm going to leave it with pi. So my answer is going to be 250 pi. Now, if this is S on top, my S was equal to R times theta. So Joseph, the other number you came up with was the radius, which is, thank you so much. So I'm going to get the 250 pi times the radius, which is 14. And then it says, what? Do you have a question, really? Okay. So I multiplied by the radius, and I have to divide by time. Well, it's the revolution per what? Minute. So I'm dividing by 1 minute. So the radius was in inches, so this is going to give me inches per minute. So 250 times 14, I got 3,500 pi. Did anybody else get that? So that's inches per minute. So this is the exact answer. That's the exact answer, but it doesn't tell us much. So if you take your little handy dandy calculator and the 3,500 pi, push the S to D button, I think you get 10,995.574 inches per minute. That was the linear speed. The linear speed, you're using this formula right here. And I always start by finding theta. So the next one says find the angular speed of the same tire. So the angular speed is the theta over time. Well, we already found theta, didn't we? It's 250 pi. So I'm going to have 250 pi over 1 minute, which is going to give me 250 pi radians per minute. So that is my exact answer. And if you type that in your calculator and make it into a decimal, you should get 785.398 radians per minute. So a CD with a diameter of 120 millimeters. Do you want to take a nap? Go ahead and put your head down and go to sleep. I bet you won't fall asleep tomorrow, will you? No, I bet not. Okay, I'm not talking to the rest of you. All right, so I'm given the diameter. Do I want the diameter? What do I want? Radius. So the radius is going to be 60 millimeters. You're fine. And it rotates at 45 revolutions per minute. Find the linear speed. So all of that information, I start where? Every single time. Find theta, and theta is going to be 2 times the number of revolutions, and the number of revolutions is 45. So I get 90 pi. So now I'm ready to use that, and I'm going to put it in the r times theta, and we found the r was 60. Wait, and that's millimeters, sorry. And then times 90 pi over, what was the time that the revolutions was in? Minute. So 1 minute here. So my V is going to end up being 5,400 pi millimeters per minute. Not always. So that's the exact answer. Push the button. So then I'm going on to angular speed. And the angular speed is the theta. Found theta. What was theta? So W is going to equal 90 pi over 1 minute because the revolutions was in minutes. So I'm going to get 90 pi radians per minute. And if I push the little button, I get 282 dot period decimal 743 radians per minute. Okay, so do you all see the difference between the linear velocity and angular? We're okay? Okay, so there's only one extra step, okay? Just one extra step. So all of these problems are all working the same. You find theta, and then just plug it back in which formula you have to plug it into, okay? So let's look at this one, and we'll do this together. So first of all, it's a 16-inch diameter. I don't ever want diameter, I want radius. So my radius is going to equal 8 inches. On a car is making 500 revolutions per minute, so I want the linear speed. So we all have to start the exact same way. The very first step, find theta. If I find theta first, I take the revolutions times 2 pi. My revolutions is 500 and 2 pi, so my theta is 1,000 pi. So now I'm going to take theta times the radius, so I'm going to have 8 times 1,000. Whoops, not 10,000. I'll show you what we're going to do. So I have 8 inches, 1,000 pi. Now, what was the time on my revolution? Because that's what always goes with the V. It's minutes. So I'm going to put 1 minute. So this is going to give me 8,000 pi inches per minute. But what does it ask for the answer in? Okay, so I want miles per hour. So I'm going to take this answer now. I'm always going to just work it this way. And then at the very end, I'm going to switch to the right labels. So I'm going to take my 8,000 pi. And that's inches per minute. Now, I want to switch to miles per hour. So I'm going to start with my minutes. I have to cancel my minutes out. So if the minutes, where does the minutes have to go to cancel? On top. So how many minutes would be in an hour? So the 60 minutes on top goes on top, and the hour goes on bottom, and now my minutes cancel. And the next thing, I need to change my inches to miles. So if the inches are on top, the inches have to go where to cancel? Bottom. So I want 12 inches in a foot. Well, now the inches are canceled, but it's feet. Is that what I wanted in? No. Well, if you were the teacher, you so you can see how to do it, okay? Switch it to miles, right? And ask why didn't I just make it inches to miles? So I don't know that conversion off the top of my head, but I know there's 5,280 feet in a mile, and I know 12 inches in a foot, so I can do that conversion, okay? But if you know it off your head, you can do it in one. Yeah, if you remember what it is, you can do it. Okay, so so where do the feet go? The bottom to cancel, right? So I have 5,280 feet on bottom and 1 mile on top. And now my feet cancel. Now to get exact answer, I'm going to multiply everything on top and get a top answer, multiply everything on bottom and get a bottom answer, and let the calculator reduce it for you. Everybody type that in. And even if you can't try it, everybody can find theta. I do. Push this button. Decimal. 420. You work. The question is, on a windmill, blade and a blade in the middle, right? So this is the radius. You get the whole blade is the radius because they're hooked in the middle. The blade doesn't move in the middle, it moves all the way. You understand what I'm saying? So it's the whole blade is the radius. Oh yeah. Wait, did you? Oh, that's okay. I don't think you did it. But that's what it. You were good. Yes. Good. It's like that should be 5,600 on top and. Yes. He's not as a. Did you get this, young child? The 60 seconds has to go on bottom because the minute has to cancel. Okay. You can check number 6. See if you got it right. So check it on this on number 7. Multiply 140, 60, and 60, and then divide by 5,280. So these really aren't that hard, right? Can we agree these are not hard at all? Okay. So I just want to do, oops. Okay. So I just want to show you one more thing, then we'll be done for today. So we said that V is equal to S over T. And I know that S is the arc length, and the arc length is R theta over T. Well, if you turn your paper over and look on the other side, what is theta? Right. So right here, I get R times W, and that equals V. So using that formula, if I find the W, right, the angular speed, I can just multiply by the radius, and that's the same thing to find V. So just like every other problem, where do I always start? Theta, and my theta is 40 times 2 pi. And that gives me pi. And so the next thing I have to do with W is I have to divide by time. And this is in minutes. So my W is going to be 80 pi over 1 minute. So I'm going to get 80 pi radians per minute. And then all I have to do to find the V is multiply by what? The R, and the radius is 25. So when I do that, (25 times 80), and that gives me inches over minutes. What is 25 times 80? I didn't write it down. 2,000. Oh, I did write it down. And that's inches per minute. Is that what I want my answer in? I want feet per second. So we have to go ahead and make this feet per second. I'm not going to do 9, so I'm going to write down here. So I'm going to have 200 or 2,000 pi I'm going to convert the minutes to seconds. So the minutes are on top to cancel, and the 60 seconds go on bottom. The inches are on top, so it has to go on bottom to cancel. And we're going to feet. So I have 12 inches in a foot. So the inches cancel, and now I have feet per second, which is what it's asking for, feet per second. And if you multiply, you end up with 25 pi over 9, or 8.727 feet per second.